On the 1st of March 1982, Venera 13, a Soviet space probe, was the first lander to transmit color images from the surface of Venus. After 4 months' journey, the spacecraft plunged through the thick clouds and touched down in the southern hemisphere of the planet. Despite Venera 13 being a hermetically sealed pressure vessel, it was designed to last only about 30 minutes. It was transmitting data for more than 4 times longer, but nevertheless, 2 hours and 7 minutes after its landing, the harsh surface of Venus sealed its fate. Venus is an extremely hostile world, by far the hottest planet in the solar system, with average surface temperature of 462 degrees Celsius. A block of lead would melt on the surface of Venus the way a block of ice melts on Earth. The pressure is about 92 times that of Earth, and its clouds are made of sulfuric acid. If a hermetically sealed space probe made out of metal had such a hard time to survive there for more than a couple of hours, how long would we, fragile humans, last in those conditions? Hi everyone, my name is Radim. Welcome to this brand new show called SpaceBased. In this episode, we're gonna take a look at the concept of manned mission to Venus and see what options we really have to explore our closest planetary neighbor. We're gonna try to answer questions such as: can we really build a spacesuit that will allow humans to walk on Venus someday? Is it even remotely possible, or is it just science fiction dream? And we also gonna talk about circumstances in which you might not even need spacesuit at all. So let's jump right in. This is launch of Mariner 2. On 14th of December 1962, it became the first successful mission to another planet when it flew by Venus as close as 35,000 kilometers. It was one of many space probes launched by both US and Soviets in 1960s, and they shook our general understanding about this planet. Until then, we thought it might be tropical paradise, Earth-like world, maybe just a little bit hotter. Past generation of science fiction writers sometimes pictured its surface as hot steamy jungle roaming with alien dinosaurs. Although Venus was named after Roman goddess of love, those spacecrafts revealed it's more like a vision of medieval hell. Solar system exploration was always driven largely by desire to find evidence of extraterrestrial life. But in case of Venus, after initial interest in 1960s and 1970s, our hopes decreased rapidly when it became clear that its surface conditions are way too extreme. The chance of Earth-like life in its toxic hellscape is almost zero, and while it might have hosted life in the past, because of its volcanic activity and constant resurfacing, it's very unlikely we will find any evidence about it. It was the first planet we reached, where we landed, but the more we learned about it, the more we shifted our focus towards Mars. But interestingly enough, in 1967, NASA actually considered a manned flyby of Venus as part of their Apollo applications program. It would use upgraded Apollo Moon program hardware and launch on top of Saturn V on October 31st, 1973, with flyby 4 months later. The spacecraft would pass Venus as close as 6,200 kilometers above the surface and at very high speed, leaving the crew with only a few hours for detailed study of the planet. At this point, a series of probes was to be dropped, and at least 2 of them supposed to land on the surface, taking photos and examining the soil. But the mission, of course, would be very expensive, and in light of budget cuts, NASA dropped most of its ambitious plans, and Apollo applications program eventually led only to Skylab, launched into low Earth orbit in 1973. Since then, the science world has been mostly fixated on Mars, but in the last decade, some scientists at NASA started to talk about Venus again. Some of the engineers even suggested a mission with astronauts on board. Options will be either flyby mission similar in concept to 1967 proposal, or maybe even manned orbital mission. But what if you are brave enough, or maybe stupid? That really depends on point of view. And you're willing to become the first man to land on Venus? Why there are no plans to send astronauts to the surface? It's not pleasant there, but hey, we are humans, problem solvers. One of the biggest problems you face if you'd like to land and walk on Venus is having a spacesuit that can keep you alive. Now you might be saying, okay, I get it, the conditions there are extreme, but without a spacesuit I'll die extremely quickly almost anywhere outside the Earth. And yet we've done hundreds of spacewalks and even some moonwalks 50 years ago. So just let me put on some upgraded, high-tech, next-level spacesuit and I should be good to go, right? No. Sorry. In order to understand why spacesuit for Venus will be such a challenge at the edge of our current technological abilities at best and definitely beyond our budget abilities, let's take a brief look at the original Apollo spacesuit. You may know this guy, it's Neil Armstrong inside the lunar lander. This amazing picture was taken just minutes after he came back inside from the first moonwalk in history. It captures the look of pure joy, disbelief and huge accomplishment, achieved largely thanks to the spacesuit he wore. The type of suit used on Apollo 11 had the designation A7L. It was made of 25 protective layers in total, but for the simplicity's sake, let's break it down into two protective envelopes. The white outer envelope is the one we usually see on pictures. It consists of many layers of different materials to stop micrometeorites and to protect the inner layer from sharp objects. It is white mainly because the white color reflects the heat, so it was also used for thermal protection. After the deadly Apollo 1 fire, it was also designed to be fireproof. This is the inner pressurizable envelope, also called the Torso and Limb Suit Assembly, TLSA in short. It's the same spacesuit, but this is the most important part that kept astronauts alive. It kept them in pressurized atmosphere, gave them oxygen and removed carbon dioxide. And underneath all of this, astronauts also wore special multi-layer liquid-cooled garment that circulated water and maintained their body temperature at acceptable level. It's an essential part. Without it, they will start to overheat very fast. It was a fully working suit that basically acted as personal spacecraft, and it was capable of protecting its owner from temperature ranging from -156 to +121 degrees centigrade. Now, this description is way oversimplified, but it helps us to understand that A7L spacesuit was a huge engineering achievement at the time, and not just at that time, even now. EVA spacesuit is a super complex machine, and in order to build one, it requires years of research and development, and also hefty budget. A7L helped to keep alive many astronauts not just only during Apollo missions, but it was also used for Skylab program. Neil Armstrong said himself, it was tough, reliable and almost cuddly. Okay, so now that we talk about the incredible engineering behind it, you might start to feel confident enough to put it on, step outside of your lander and try it out on Venusian surface. Actually, you probably wouldn't last long enough to take the first step. Okay, obviously this is not good news for us, so we have to go back to the drawing board and start pretty much from scratch. Now, why our Apollo suit actually failed, like specifically? The extreme heat of 460 degrees Celsius is obviously just way too much for this spacesuit to withstand. Remember, it was designed to operate up to maximum 121 degrees, and Venus' surface is almost 4 times more than that. But in fact, even if the temperature there would be just only 120 degrees, you wouldn't really last much longer. Thanks to the heat conductivity in its thick air, you'd be cooked alive sooner or later. But we need to talk about our biggest enemy here, and that's atmospheric pressure. Apollo A7L suit was designed to hold internal pressure of 3.7 psi against the vacuum. There is no significant pressure at the moon's surface, so during Apollo missions, the pressure differential the suit was facing, and the pressure differential is the important thing here, was therefore just those 3.7 psi. Now, on the surface of Venus, there is, in simple terms, quite the opposite of vacuum. Pressure there climbs up to staggering 93 bars, which is about 1350 psi. That's about equal to the pressure found 900 meters underwater on Earth. So if you happen to be inside of your lander on Venusian ground and you just simply can't wait to open the hatch and finally get out, you might wanna hold on for a bit. The moment you'll do it, your spacesuit, designed to withstand pressure differential of 3.7 psi in vacuum, is instantly facing the opposite, crushing force of almost 1350 psi. Saying that you don't stand a chance is understatement. For comparison's sake, picture a party balloon. It's currently above the water level, it's full of air. Now it starts to slowly submerge, then going deeper and deeper, balloon shrinking more and more, until it will be deep enough so it will appear completely void of air. And despite the fact there is still the same amount of air, it looks completely flat. And now picture yourself in that balloon. The only difference is on Venus it will happen instantly. So what direction should we go in designing spacesuit with those conditions in mind? This is Atmospheric Diving Suit, ADS in short. It's basically a personal submersible designed to maintain interior pressure of 1 atmosphere despite the exterior pressure, and divers using them are called aquanauts. It looks so cool, doesn't it? Yes. That's how I feel sometimes myself walking around. It can be used for very deep dives, up to 700 meters for several hours. That's not exactly 900 meters we will need for Venus, but hang on. This one, for example, named Nude Suit, is certified only to 300 meters, but it has been tested all the way up to 900 meters fully working. And that's what we need. Plus we also need significant budget at our disposal. This type, ADS 2000, is capable of operating up to only 610 meters, but from the project's beginning up to until 2011, the US Navy spent $113 million for its development. Let's compare that to the Apollo A7L spacesuit mentioned before. In 1960s, NASA negotiated contract valued at $1.65 million, which would be about $13.5 million in today's money. That's more than 8 times less. But it's fair to say that was just initial cost plus contract. Also nowadays, the development and testing of modern spacesuits is fairly more expensive. For the new Artemis spacesuit, estimates range as high as $250 million. But anyway, you get the point, ADS diving suits are not cheap by any means. Now let's say our research and development team, heavily inspired by ADS diving suits, figured out how to overcome that nasty surface pressure. So now we have to address the heat. Stepping out of a spacecraft on Venus wearing only improved, upgraded ADS diving suit might not be a good idea either. At first, the heat will start to cause problems on the outside of the suit. Those suits are often made from aluminum, and that's certainly not going to work here, as it will have lost too much strength due to the temperature. And that's exactly why we should go with titanium as our material of choice. Toughened titanium alloy will increase the pressure resistance of our spacesuit. Titanium also shows quite remarkable corrosion resistance, and frankly that'd be great in ever-present haze of sulfuric acid. But ultimately, slowly but surely, we're gonna be back where we were using Apollo A7L. Our suit will start to massively overheat, and so will we inside of it. Sure, we're gonna do everything we can in terms of thermal insulation, but there is really no escape from 462 degrees centigrade. And let's say that even in this suit, we are wearing undergarments circulating cold water all around our body. But that's necessary for any spacesuit. It's for the purpose of managing heat generated by our body, which is around 37 degrees. It's not really helpful when you happen to find yourself inside a wood-fired oven, in which pizza is cooked in about 90 seconds. And you will not last much longer. So in order to not being baked alive, we need to come up with some additional and very powerful active cooling system inside the pressurized part of our spacesuit. Using liquid nitrogen as our cooling agent seems like a very good option. Having a large tank of liquid nitrogen sounds even better, because the time we can spend walking outside would be limited by the amount of nitrogen we will have. Now, if you'd like to do more than just a few steps, plant the flag and take Venetian selfie, having a classic spacesuit backpack might be a bit impractical. It's not just the amount of nitrogen we will have to carry, but we need also a lot of batteries so we can supply power to our cooling system. Instead of having giant backpack, it might be more feasible to land with some sort of rover that will give us company while carrying all that nitrogen and batteries for us. We will connect ourselves to the rover via umbilical cord, and then we could stay out maybe a couple of hours exploring the magnificent hellscape of Venus. Now we are almost ready, but there is one last obstacle we've got to address: the gravity. On Venus, the gravity is almost the same as on Earth, only about 10% less, which is great in terms of muscle and bones density loss, but not so much great taking into consideration the weight of our monster titanium armored spacesuit. So the last thing we need to add into our design is full body powered exoskeleton. Without it, we will not be able to move a finger. It will make our suit more power hungry, but our rover body already got us covered. Does that sound completely crazy to you? Submarine-like spacesuit with what? Rover body? Are you completely out of your mind? Well, yeah, welcome to Venus, where the impossible is inevitable. Okay, so now we've successfully designed hard shell spacesuit for the surface of Venus. Congratulations! So although the idea we've discussed here today is currently closer to the science fiction than to anything else, the concept of hard-shell spacesuits is not something new to NASA. This is AX-5 prototype spacesuit. Engineers at NASA's Ames Research Center worked from 1960s to 1990s on a series of hard-shell spacesuits designed to provide more freedom of movement to the astronaut while being pressurized to the higher level than soft spacesuits. Talking just about its appearance, it might not be that far away from how actual spacesuit for Venus would look like. We can speculate that it will have a bit more metallic look because of its titanium construction. So in the end, this is my best Photoshop attempt to visualize how astronaut on Venus could look like.
Are you German?
I just couldn't help myself, I love that movie. Now let's try to tell a little story. Once upon a time, in the near future, there was a very ambitious space program full of scientists passionate about Venus exploration. And they've prepared blueprints for amazing spacesuit, which would allow astronauts to do several hours of EVA on the surface. The program was moving very fast. They were also getting ready everything else needed for upcoming manned mission. Everybody was totally excited, but then some less enthusiastic member of the team unexpectedly looked at the numbers and found out that building such a spacesuit would probably cost about $1 trillion. Which would be even more than the whole SLS program. Actually no, SLS will probably cost even more than that. That's beyond Venus level, that's like interstellar level. Okay, sarcasm aside, you've got the point. So what now? Is this the end for us? Dream of going to Venus will not become more than just a dream? Or do we have some other option in which we don't actually need spacesuit at all? This is Project Havoc, NASA's conceptual manned mission to Venus. The idea behind this mission is not to land people on the surface, but to descend into the atmosphere and inflate the airship with people on board. Once inflated, the crew would live in the airship for 30 days before returning to the orbit and then back to the Earth. This concept is not something new. As surprising as it may seem, the upper atmosphere of Venus is the most Earth-like location in the whole solar system. At 55 kilometers, the pressure is half bar or 7.3 psi, which is roughly equal to 5 kilometer elevation on Earth. Not bad at all. And the temperature is actually pleasant 27 degrees. Another really good thing is, The oxygen at those altitudes is lifting gas, so you don't have to bring some crazy amount of helium with you. Your airship can be lifted by the same air you'd breathe. And guess what? Venus's atmosphere is 96.5% carbon dioxide, and you can make a lot of oxygen from extracting and processing it, so you don't have to bring tons of oxygen either. So we're finally ready to answer the big old question. Can you survive on Venus without a spacesuit? And the short answer is yes, but don't forget your oxygen tank. Once again, at 55 kilometers, pressure is about half sea level pressure on Earth. So you should be able to survive without any hardship as long as you have a respirator and enough of oxygen-rich air in your tank. While it's 27 degrees outside, wearing a shorts is not a good idea. At this altitude there is still sulfuric acid present in the atmosphere. While it will probably not kill you, you might not want this stuff to get onto your skin. So some acid-resistant lightweight pants and long-sleeve t-shirt with gloves should do the trick. But be careful when coming back into your habitat, because of the sulfuric acid possibly accumulated on your clothing. Perhaps you might want to get a shower. If your airship would have some nice deck, you could just open the hatch of your airlock, walk outside, sit there and enjoy the spectacular view on the sea of clouds, wearing only oxygen mask and some acid-resistant clothes. Just be careful and remember what is down there under your feet. You really don't want to fall off your ship. So we spent this video taking a look at the options we have in terms of manned mission to Venus. More specifically, rather more detailed look at the spacesuit needed for such a mission and when you don't need one at all. Any possible future mission to the surface of Venus, whether it's gonna be in 50 or 500 years from now, will have to solve gazillion more issues. Not that I know what I'm talking about, but I certainly can imagine the development of the stuff we've discussed here today will be way more difficult in real life than in YouTube video. Let's say you've got everything ready to perform successful landing, and you've got even spacesuit to survive down there. But we didn't mention anything about the return part of such a mission. Venus's gravity is pretty similar like here on Earth, but the atmosphere is so dense that the drag on the ascent will be enormous. Some estimates suggest that you'll need as much as 27 kilometers delta V budget to get your ascent stage into low Venus orbit. That's nearly 3 times more than is required to achieve low Earth orbit. Now you might think, okay, so in this case I need rocket 3 times bigger than I thought. If you are a Kerbal space program addict, as I am, you already know where this is heading. The reality for you is actually much worse. In this situation and in any other different situation involving rockets, the notorious Tsiolkovsky rocket equation applies. It's unforgiving, and especially so in case of Venus. The actual size of the rocket you'd need depends on many things, such as staging for example, and we're not gonna dive into details in this video. But to put it simply, your return vehicle would not be massive just in its size, but also in its complexity. Engines like Merlin or Raptor wouldn't simply work there because of the surface pressure. Using aerospike engine might be a solution, but your ascent module will be still gigantic. However, there are 2 feasible options. One is air-launched rocket similar in concept to Virgin Galactic spaceship or Northrop Grumman's Pegasus. But that implies you have some sort of runway at your disposal, or your vehicle will launch using helicopter blades like a rotary rocket. Second and arguably more elegant option would be using balloon to lift you off the ground and then ignite your engines once you are at altitude with acceptable pressure. Either way, you're gonna have to lift yourself up into pressure zone, which will allow engines of your rocket to work. Launching directly from the surface means your vehicle will be so incredibly complex, you might just as well build a spacelift on Venus, and after that you don't need to worry about rockets anymore. Okay, so to wrap this up, let's ask ourselves, is it really impossible to land astronauts on the surface of Venus? Well, it doesn't break the laws of physics, so you can't really say it is. But would be such a mission impractical and obscenely expensive? In the near future, absolutely. Although I have to say it will be quite cool. Unfortunately, I think we're not gonna see Mondoshivan astronauts roaming Venetian surface anytime soon. But what about orbital man mission like Havoc and its potential to create floating colonies above the clouds? No spacesuit is needed for such a mission, and returning back to the Earth will be way easier. While it looks like this project has never moved beyond conceptual phase, the idea is definitely exciting, and I really hope that one day we're gonna explore that further. In the near future, with SpaceX's Starship or any other reusable launcher being operational, we certainly gonna have more options at our hands. However, there are many questions with regard to the mission like Havoc that must be answered before we actually send any humans there. Just to mention one, airship is kinda fragile thing, right? Yes, I know that was hydrogen, and airships nowadays are using mostly helium as lifting gas, and on Venus we would use oxygen, but still, those vessels would be under permanent mechanical stress in combination with occasional sulfuric acid cloud passing by, not to mention high wind velocities. It seems that manned mission like Havoc requires higher level of sophistication and bigger budget than manned mission to Mars, for example. But the robotic version of such a mission sounds like a first important step in the right direction. In reality, we know so little about Venus, at least compared to Mars, and quite frankly it's a shame. I personally hope that in the near future we're gonna send there some advanced robotic missions. It's been quite a while since last Venera's landing. There are also some interesting rover concepts, but in the end it's all about the funding. In case of NASA, Mars was and still is the priority, but with global warming causing issues here on Earth, the future mission to Venus could help researchers gain a better understanding of the planet's changing climate. So such a mission could benefit all of us. And finally, robotic missions could also pave the way for any future crewed missions, so ideas like Havoc could receive proper funding and become more than just a concept. Okay, I think that's it for this episode. Thank you guys so much for watching. I really hope you guys enjoyed this video. It's a new channel. So if you like this video, please subscribe and also hit the notification bell so you won't miss the next one. I've oversimplified so many things, so if I got something wrong, and I'm sure I've got plenty of things wrong here, please don't hesitate to let me know. I'll really appreciate it. Some of you might have some better and less ridiculous ideas about spacesuits for Venus or manned mission to Venus. Maybe let's have a discussion in the comment section down below. Okay guys, thanks again for watching. Bye everybody.